Good morning, everyone. So, we have started with chapter light, and in continuation of that, today we'll study about the topic sign convention for reflection by spherical mirrors. As you all know, that in the last few classes we have learned about the image formation by spherical mirrors. But what if somebody will ask you for the exact measurement of the image formation for different object positions? For that, we'll be needing mirror formula as well as magnification formula. And to use these two formulas, we must know the rules for the sign convention, right? And in order to understand this sign convention for reflection by spherical mirrors, let's recall number line which you have already studied in your maths in your junior classes. So let's start with your first topic today, that is sign convention for reflection. So let me draw a number line for you. This is your y-axis. This is your x-axis. So this one is your x-axis and this one is your y-axis. This is said to be the origin. Now as we all know that on the right hand side, all the numbers on the x-axis are taken as positive. On the left side, they are taken as negative. Similarly, for the y-axis, the numbers in the upward direction are taken as positive and in the downward are taken as negative. Right? Now you might be thinking, what is the relation between number line and the sign convention rule? So let's see. So first, this y-axis, I'll replace this y-axis with the concave mirror. So this is your concave mirror and I can place on the non-reflecting side, I can place the dashes to distinguish between the reflecting and the non-reflecting side, right? And in between this, as you all know, that this is known as aperture and the center of the aperture is known as pole, right? And this pole is same as the origin in case of number line. So as we all know that in case of number line, all the distances are measured from the origin. So here in this case, all the distances are measured from the pole, right? Now this principal axis, this x-axis is considered to be as the principal axis here, right? Now these are the few basic things we must know. Now suppose another thing here is, suppose I am placing the object here. And as we know that all the distances are measured from the pole. So this distance, suppose I am saying this is the object. So the distance between the pole and the object, this distance is known as the object distance and which is represented by u, right? So this distance, the distance between the pole and the object. Similarly, suppose image is formed somewhere here. So this is image. And what is the image distance? How we can measure the image distance? That is the distance between the pole and the image. So this distance between the image and the pole is known as image distance, which is represented by V, right? So these are the few basic things. So before moving on further, let's write down these few things to avoid the confusion, that the distance between the object and the pole of the mirror is called the object distance, which is represented by U. Similarly, the distance between the image and the pole of the mirror is called image distance, which is represented by V, and the principal axis of the mirror is taken as the x-axis and the pole of mirror is taken as the origin, right? So the first rule says that the object should always be placed on the left side of the mirror, right? So this is the left side of the mirror. That means the direction of incident ray which is coming from the object is always from left to right, right? So this is the direction of the incident ray. Now all the distances are measured from the pole, right? The distances which are measured on the right side of the pole are taken as positive. So these are the positive distances. And the distances which are measured to the left of the origin are taken as negative distances, right? So now you can compare here this with your number line, that the numbers which are on the right side are taken as positive and the numbers on the left side are taken as negative. So similarly here, the distances which are measured from the pole towards the right side are taken as positive, and which are taken as towards the negative side are taken as the negative. Right? Now, very important thing here is that this rule can also be defined as the distances which are measured in the direction of incident ray are taken as positive. So what does it mean? Because since you can see that the object is placed on the left side, right? So the direction of, as you can see that object is placed on the left side of the mirror, right? So the direction of incident ray is from left to right. So the positive distances are measured in the direction of incident ray. Although the distances which are measured on the left side are opposite to the direction of incident ray, right? There is one more rule that the heights of the image or the object will be measured from the principal axis and perpendicular to the principal axis. So somehow if I am saying the image is formed here, then the upper side upward and the perpendicular direction to the principal axis are taken as the positive height, and in the downward direction perpendicular to the principal axis are taken as negative, right? So all these are the rules for the sign convention for spherical mirrors. So what are the rules? Object is always placed to the left of the mirror. All the distances are measured parallel to the principal axis, and from the pole of the mirror, all the distances measured to the right side are taken as positive and on the left side are taken as negative. Heights are measured perpendicular to the principal axis, and in the upward direction they are taken as positive, in the downward direction they are taken as negative. So all these are the rules. Let's see what is the application of these rules. So here I have a concave mirror. I am making the table here for concave mirror and the convex mirror. So let's see how we can apply that. In case of concave mirror, so U is your object distance. In case of concave or convex mirror, in both the cases, okay, one thing is that I have drawn the concave mirror for you, right? But the rules are same for concave as well as convex mirror, right? So U is the object distance here. So in both the cases, the object should be placed on the left side, and the distances on the left side are taken as negative. So in both the cases, U is always negative, right? So for the better understanding, let me draw a diagram, a small diagram for you. Suppose this is your concave mirror, this is your principal axis, pole, and I am placing my object here as per the sign convention, right? Now what about V? That is your image distance. In case of concave mirror, we have done 6 diagrams, and out of those 6 diagrams, in 5 diagrams we got real image, right? If the image formed is real, then in that case the image formed should be in front of the mirror, that means to the left of the pole. So in that case V is negative here, right? But what if the image formed is virtual? So where the image will be formed in this case? So in this case it is behind the mirror. Behind the mirror means right to the pole. So right to the pole means positive, right? What about convex mirror? In case of convex mirror, the image formed is always virtual. So it is always positive, right? Let's talk about H. H is the height of the image, right? So it is always in the upward direction. We are keeping it as per the convention. So it is positive. Similarly for here also, convex mirror, it is positive, right? Now, what about H dash, which is your height of the image? Let me write it for you. Height of image, right? Now, in the case, if the image formed will be real, then it will definitely be inverted as well. And the inverted image, so you can see here in the diagram, inverted image. This is your inverted image. So inverted image means below the principal axis, so it will be negative here, right? And if it is virtual, then it will be erect also. So in that case, erect, that means above the principal axis, so it will be positive, right? In case of convex mirror, we always get virtual and erect image, so it is always positive, right? So the last is your principal focus. So principal focus, as you know, in case of concave mirror, it is in the front of the concave mirror. So in front means negative, that means on the left side, and for convex mirror it is behind the mirror, so it will be positive because it will be towards the right of the pole, right? So these are the rule, I mean based on the sign convention rules. So these are the signs for image distance, object distance, height, and height of the image object, and these signs will be using for solving the numericals. All right, so let's study about the mirror formula. 1 upon f is equal to 1 upon v plus 1 upon u, and as we know that u is your object distance, it is your object distance, v is your image distance, and f, as you all know, it is your focal length. Right? So if we know about v, u, we can find out f, and suppose we know about where the object is placed and we know the focal length of the your spherical mirror, so in that case we'll be able to find out the exact position of the image. So next we'll study about magnification formula. Magnification, it is represented by m. The formula for this is h dash upon h, where h is your image height and h dash is your image height and h is your object height. So let me write it down for you. That is image height and h is your object height, right? Another formula for this is minus v upon u. So what actually the magnification is? Magnification gives us the relative extent to which the image of the object is magnified with respect to the object size. So this is clear from the formula as well, since it's a ratio of image height and the object height. So how much image size is magnified with respect to your object size? So this is your magnification, and looking at both the formulas, you can see that magnification is the ratio of two similar quantities, so it has no units, right? So what other information we can get from the magnification? So suppose the magnitude for m is greater than 1. So what does it mean? That means h dash upon h is greater than 1, right? If it is greater than 1, it can be greater than 1 only in the case when the numerator is greater, and which is image height. So in this case we can say h dash is greater than h, that means image is magnified. So your image is magnified here. Next one, suppose m is less than 1. So this ratio h dash upon h is less than 1, and when it can happen? When h, that is in the denominator, object height is greater than the numerator. So in this case h dash is less than h. So here your image is diminished. In the last case here, that m is equal to 1. That means h dash upon h is equal to 1. And this is the case when h dash and h are equal to each other. That means image height and the object height are same. And do you remember that out of the 6 cases for the image formation by concave mirror, which one is this case when the image and the object height are same? So this is when you are placing the object at C, right? Now this was all about the magnitude. Now there's another set of information we can get from the magnification from its sign. Suppose m is negative. So in that case, the nature of the image, we can conclude that nature of the image here is real and inverted. Similarly, if m is positive, we can say the nature of the image is virtual and erect. Let's verify this. Suppose take one of the two formulas. Let's take the first one, that m is equal to h dash upon h. And we are considering that the nature of the image is real and inverted. So let's substitute the sign convention rules here. So h, that is object height, it is always positive. If it is real and inverted, images are real and inverted. Inverted means below the principal axis, that means negative. So in totality, answer will be negative here. So if it is negative, image is real and inverted. Let's verify this for virtual and erect also. So in case of virtual and erect, object height, it is always positive. Erect image, that means above the principal axis, so it is positive. So this one is your positive answer, right? So magnitude of the magnification gives us whether the image is magnified or how much it is magnified or how much it is diminished. And the sign of the magnification gives us the nature of the image, virtual, erect, real or inverted, right? Now keeping in mind all the things, your magnification formula, mirror formula and the sign convention rules, let's do one numerical here. An object 4 cm in size, that means h is given to you, that is 4 cm, and which is placed 25 cm in front of the concave mirror. So u here is 25 cm with negative sign, because object distance is always negative. Focal length of the concave mirror is given to us, which is again negative, minus 15 cm, and we have to find out where we have to place the screen. Place the screen means where we'll get the image, so we have to find out v here first. And next we have to find out the nature and the size. So let's see how we can do it. So let's use mirror formula here, 1 upon v plus 1 upon u. So 1 upon v we can write down 1 upon f minus 1 upon u. Let's substitute all the values. Minus 15 minus 1 upon 25. So here let's take LCM here. LCM will be 15, 25, that will be 75. 15 5s are plus 25. So negative, both the negative sign gives us a positive sign. So 25 here it's 3, 25 3s are. So your answer will be minus 2 upon 75, right? So this is the value of 1 upon v. So what is v here? That's the reciprocation of that with the negative sign. So if I'll solve it, I'll get my answer 37.5 centimeter, right? So this is your first answer. Now we have to find out the nature. So looking at the sign of v, this negative sign indicates that nature is real and inverted, right? So you must write down the reason in the bracket that why it is so, because negative sign of v indicates that the image is real and inverted. And the last one is size of the image. So size of the image, for that we are using magnification formula, h dash upon h. So minus v upon u. So h dash will be equal to h minus v upon u. Substitute all the values. H is 4. V is minus of the formula and minus of the v. Then u also negative, that minus 25. So I'll get my answer here, minus 6 centimeter. So this is the size of the image. Now here you can verify here also that since the size of the image, it comes out to be negative, that means inverted. So nature of the image again here is inverted, that means real and inverted. So this is how you can solve your numericals, right? So this is all about today's topic. So let's check your knowledge. All the distances are measured from, so try to give the answer for that. All the distances are measured from the origin, that is pole, right? So symbol U represents here object distance. Magnification is real and inverted, we have just done in the numerical, that is it is real and inverted when it is negative. What is mirror formula? That we all know. So mirror formula is, let me write this for you, 1 upon f, 1 upon v plus 1 upon u. If v is negative, that means it is on the same side as the object is, so it is real. So I hope all the concepts are clear to all of you. So this is your homework. You can practice these numericals at home, and you can practice your numericals from the NCERT also. And in case of any doubt, please come up with your doubts in the next class. Thank you so much, everyone.